Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, today we are starting problem on AFD, SFD and BMD. Let's see. Now this is a problem number 1 on AFD, SFD and BMD. The problem is given over here. Analyze the frame as shown in figure. This figure will be shown over here. Now draw free body diagram of each member and construct AFD, SFD and BMD. In frame we have to construct a part. See, this is written over here, free body diagram of each member. In this AFD, SFD and BMD, we can take the individual member to draw the AFD and SFD and BMD diagram. This AB part, then BC part, then CD part. Now first what you have to calculate? First you have to calculate the reaction. In civil engineering or in structure analysis 1, the first part which come in mind in picture is find the reaction first. So first find the reaction as it is the question is given. No change in question, please. Now let's see. This is, we don't know the value of VA, so this value is VA and this is your H. This is your H. This one is your H. Okay. Now this is your HA. This is the roller part, so VD. See students, if you don't know the value of VA and H, always take the towards the point. This one upward and this will go left to right only. Now take the moment over here. Now our first part is nothing but support. Our first part will be support reaction calculation. In support reaction calculation we will see we have to find this value VD, so we have to take a moment over here. Now taking moment at A equal to 0, always write the sign convention clockwise positive. Okay, now let's see how it will become. See, you are taking moment over here, so take a rod and put it rod over A and see this 10 kilonewton will go like this. This will be moving on clockwise direction, so 10 into this distance will be 2. So our first value will be 10 into 2. Now see this UDL, as you all knows how to convert the UDL into point load. This 15 into 4 into 4 by 2. This will become over, this distance will be 4. So 15 into 4 will be is load and in distance will be 2. 4 divided by 2. So you can write over here plus 15 into 4 into 4 divided by 2. Now why we are taking plus? Because we are taking moment over here. This is coming from upward to downward, so this will go like this, so this is also clockwise, so plus 15 into 4 into 4 by 2. Now this unknown VD will be go like this. This will go anti-clockwise direction, so VD into this distance will be 4 minus VD into 4 is equal to 0. While solving this, you get the value of VD. Your VD value will be 35 kilonewton. Okay, your VD value will be 35 kilonewton. After that summation Fy equal to 0 upward positive. Okay, always write the sign conventions, please. It's a request for you, always write the sign convention. We cannot, its accurate answer will become. Now we have got the value of VD. Our VD value will be 35 kilonewton. Now we have to find the VA value. Now VA will be, this will go upward, so positive. This will go upward, will positive. This UDL will be negative. No need to take this 10 kilonewton because it is not in vertical direction, it is in horizontal direction. But horizontal direction we are taking in X, we are in V we are always taking the vertical directions. So VA minus 15 into 4. See, this is a point load. Sorry, how to convert UDL into point load? 15 into 4. This is your load. So 15 into 4. After that plus this VD value will become 35. 35 is equal to 0. While solving this, you get the value of VA. Your VA value will be 25 kilonewton. Okay, 25 kilonewton. Now what about this? This is your x part. So in frames we have taken also summation fx equal to 0, this as positive. We are going from left to right, goes negative, positive, sorry. Now see the diagram. As you all know, this horizontal direction only have 10 kilonewton. This is good, this direction, so positive, then 10, and this also we are taking as a this direction only, so this will also got plus HA is equal to 0. Now we got the HA value will be minus 10 kilonewton. Minus 10 kilonewton means your HA will be 10 kilonewton, which will be look like this direction. Your 10 kilonewton will be in this direction. So just simply, if you got the value of negative, just simply rearrange the sign convention. We are taking over here, just take the original one over here. This is your original one. HA will be 10 kilonewton. Now in diagram you can follow this sign convention, not this one. You can follow this force only, this black one, not red one. Okay. Now after that we can now see we are done with the HA, VA and VD. Now what is our next part? Next part we have to draw the individual part of SFD and BMD and AFD. Now we are done with this part, VA, HA and VD. Now we have to take the separate part and draw the AFD, SFD and BMD of that part. Now first we are taking considering part AB. Now we have to consider at the time of considering part AB, just draw the free body diagram of part AB. This is your A, this is our B, AB part. Now in exam, while drawing the free body diagram of AB, always remember when we are drawing part AB, just put it the load over here. This VA will be 25, so put over here, this one is 25 kilonewton, and your 10 will, this is your 10 kilonewton which is here, so this one is 10 kilonewton. Now this one is also given 10 kilonewton. Now in exam you have to balance A part. While seeing the part of A, you are cut the part over B, we are cut the part AB, so separate the AB part as here. We are drawn the AB part over here. Now what will we do? You have to do, you don't have to remember these things, you have to neglect this part BCA as you all known here. Now we have to balance the B part. While seeing to A, we will not see the original diagram to see where yes, this UDL is there, this load is there. Always neglect this part. You can see only this part A and B. As you imagine that we are only have two parts A and B. While seeing the A, we have to balance the B part directly, not see the over B after B. Okay, so please remember this thing. This will in exam, this is very sensitive part of this chapter. We have always take this section. When we are taking the section of AB, always see the AB part, not this rest part. Will be no use of this rest part for this term, this type. Okay, now we have to balance the B while seeing the A part. Okay, only A part we are, this is the possibility in these chapters. So see this 25 kilonewton going upward. Okay, now in this chapter says that every part must be under equilibrium, every joint must be under equilibrium. Okay, so we have to equilibrium that member. So if you are taking 25 kilonewton coming from downward to upward, so to oppose this force, we have to apply this 25 kilonewton from upward to downward. This is your 25 kilonewton. Now see, this one will get constant, this value will get 0, so this can be under the equilibrium part. Now let's see, this 10 kilonewton going this side and this 10 kilonewton will go this side, so this part is always balanced. This is your plus, this is your minus, always it will get balanced. So in this part here, this one will be 0, this is your 0. Now what you have to do, just simply extend this part, Now you have balanced this directly. You have to balance the, or you can use the summation fx is equal to 0, summation fy equal to 0. This is also possible, but always remember, if see this is going upward 25, downward 25, this will go 10 this side, 10 this side, this will be balanced, equilibrium in part, so this will become 0. Now you have to draw the AFD, SFD and BMD of that part. Now first one is AFD. Now how will you draw AFD? First draw the one line and see what is the sign conversion following on for the AFD. Now let's see now how to draw the AFD. So first, see, this is a sign convention of AFD. See, this is section, this will come from here, this is come from here, so this will be compression will be minus sign. So see, this will be go minus, so this will become like this. This is your A part, this is your B part, this will come minus sign. Okay, now see, always remember one thing. See, this is your diagram. You are stay over here, you are standing over here in inside of the frame, so you are seeing from AB from this side only. Okay, so whenever the negative sign comes, you have to draw inside the frame, and the positive sign will come, you have to draw the outside the frame. Okay, this will be remember. So we got the value of this compression, this will be got minus, so we will draw the minus inside the frame. So see, we are drawing the FD inside the frame, will become here. Okay, so we are drawing like this. This is minus because our this value will be minus, that's why. See, this is going compression, this is minus, this is going tension code plus. Okay, this remember first things. Negative sign draw inside the frame, positive sign draw outside the frame. Okay, now let's see the SFD of that part. Now see, shear force. Now shear force calculation, you can directly solve this shear force diagram, or you can calculate also. See, put just take like this. See, like this, shear force A at left equal to 0, shear force A at right equal to something, shear force 10 at left something, shear at right something. So, or you can directly solve. See, this will become 10 upward, so this will be go 10 upward positive. Okay, now this will be go 10 as it is, this will go 10 downward, this will go 10 downward, this value will be 0. Why 0? Because there is no load over here. So this is your AFD part, this is your SFD part. Directly you have to solve, write it over A, this is your B part. See, this is positive sign, this is positive signs, means this is from outside the frame. See, this is outside the frame, like over here. Okay, now in exam you have to find the SFD and BMD. No need to solve AFD left equal to 0, right equal to 0. Directly you have to solve the diagram. Now the bending moment diagram. For bending moment diagram, remember one thing. For bending moment diagram, always take the bending for bending moment diagram. Always see the original diagram. Okay, so I'm writing over here note for bending moment diagram. Always remember and see the original figure. For bending moment diagram, always see the original diagram of given in the questions, because we are in bending moment either taking left or right. This is very important. So we are taking the bending moment at A. The bending moment A will be 0 because in downward there is no load. But in bending moment at B, there might be some bending moment, and this part will also some bending moment. This part, X, as you know, bending moment at B. Okay. Now let's see what is bending moment at B. See, name it as D. This is as E. Okay. Now see the bending moment at D. Now write it over here. Bending moment diagram. See, bending moment at A equal to 0 because of no load over left side. Now bending moment at E is equal to, name it as E. E is equal to, now what is E will become? See the original diagram. We are taking bending moment here. Either you can consider this whole part or this part. So what we are considering? We are considering this part. See, just put over here and see this. What is your sign conversion in bending moment? This is your sign conventions. Okay. Now just see over here. See, this will be go upward. So 10 into this distance will be 2. This will come plus 10 into 2, it will be go 20 kilonewton meter. Now bending moment at B is equal to, now bending moment at B equal to C. Now bending moment B equal to, either you can take this part or you can take this whole part. We are taking this part, put it just like this, and see, we are taking bending moment over here. This will come 10 into distance 4, 10 into 4 positive, then minus, this will go hogging part. See, this will be go like this. This is nothing but hogging part, and this is your sagging part. So plus 10 into 4 minus 10 into 2 is equal to 20 kilonewton per meter. Okay, now draw the bending moment diagram. At A, that will be 0. Now at E, this will be 20. Now this one also have 20. This is your bending moment diagram. This is positive. C, this is positive away from the frame. This diagram will be like this. Okay, now here we will done with this part of AFD, SFD and BMD. Okay, now after that, now we are done with the AB part. Okay, now we have done with the AB part, but always keep remember, for bending moment diagram, always see the original diagram. Please this point note it down very carefully. In bending moment diagram, while drawing the bending moment diagram, always see the original diagram given in the question. Okay, now we have done with the A and B part. Now we are solving this, another part will be B and C. Now draw the FBD of BC part. Now consider BC part. Now draw the FBD of that part. Now for this part, you can just simply see this. See, this is 25. For this joint to be in equilibrium, this, if this will go downward 25, then this will go upward 25 kilonewton. Okay, this will go downward, this will go, this value is got 0, so here only this will also have 0. Or you can solve like this also. This is get 25, directly transfer over B, or this value is constant 0, so it will get 0 over here only. Okay, now what to do, we have to balance the part B and C. While seeing the B part, you can balance the C part. Okay, now while we see this part, balance this part, this value will be 15 kilonewton per meter. Now let's see how to will balance. First, students, see, this will go upward 25, but downward come will be 15 into this distance is nothing but 4 meter. 15 into 4 is how much? 15 into 4 is nothing but 60. So 60 minus 25. See, this will go upward, so 25. Now this will go minus 15 into, is how much? 15 into 4. This value will become 25 minus how much? 25 minus 15 into 4, 60. Then we get the value of 35. So we have to apply the upward as 35 kilonewton. Or you can see in the diagram, see, this is your 35 kilonewton, directly you have put it over here only. This is also the criteria for solving this one. Okay, now you have balanced this part. This is your B0 part, and this is also your 0 part. Now always remember, now after that you have to draw the diagram of AFD, SFD and BMD. Now let's draw the diagram first. Okay, now first draw the AFD part. First draw the AFD part. This is your AFD part. In AFD part, we have to take either tension or compression, but their AFD part will be 0 because there is no value. So your AFD will be 0. This is B, this is your C. Now after that, SFD part. In shear force diagram, you can directly solve over here only, or you can directly solve. See, in bend, see, this is your 25 kilonewton. We are taking section over here. This will come 0 over here. This will come positive 25, because at section left side positive will be, the upward will be positive. See, this one will be positive like this, and if this is 35 will be like this. This is 35 and this is 25. You can solve over here only. You can solve in the exam, you can solve by section x is a, sorry, b at left equal to 0, b at right equal to 25, c at left equal to 35 minus something. You can solve it by own also, or you can solve by exam in paper also. I am solving the direct because you are studying the essay too. Now see, this diagram will come this here where the shear force is. Now see, this B and C, this AFD will be 0. This is your B part and this is your C part. Now what we have to do, you have to directly draw the diagram. Okay, now here the bending moment will be maximum. As you all know, where shear force is 0, the bending moment will be maximum. This is bending moment diagram. Okay, now this is shear force diagram, this is bending moment diagram. Okay, write it at downward. Okay, now what you have to do, as you all know, we can find the bending moment at B over here only. See, as you all know, for bending moment diagram we are always seeing the original sums. Okay, always see the original diagram. This is your original diagram. Okay, now see, we are find the bending moment at the previous one in AB. So direct write on the sums. Okay, see, this will find bending moment at B will be 20 kilonewton meter. So directly solve it over here. This will become 20 over something over here. Now what about this part? Now what about this part? This part directly you can draw like this. As you all know, this part will be maximum. Directly you have to draw like this. Okay, this is inclined straight line. This is nothing but parabolic curve. This is parabolic curve. In bending moment at C will be, while we are see the diagram, bending moment at C will be 0. Why 0? Because we are taking bending moment and can take this section. In this section there is no horizontal force. So if force is known with the horizontal, so no need, there is bending moment will be 0. Or you can take this whole part, or you can take this part. We are taking this part. In C to D there is no horizontal load. That's why the bending moment at C will be 0. This is your bending moment diagram, positive. See, this is positive. We are drawing away from the this frame. Okay, now let's consider the fourth one. Now fourth part will be part C and D. Now consider part C and D. Your C part will be this. This is your C part, this is your D part. Draw the FBD of that part. This is your C, this is D. Now as you all know, this has 35 kilonewton. Now in CD part, now as we are taking at AB part, just see the CD part. There's the value of CD and balance. See the forces over D and balance the C. Not we have to see your this, we can balance like this also. See, this will come 35 upward. So at the time of C, in the next part it will go downward. Or directly we can balance from here only. This part we can balance over here. This part will balance over here, and this part will be balanced. We can see this part or this part, or directly you can oppose this part over here. Okay, now in this part 35 kilonewton will be like this. So this will come 35 kilonewton. There is no horizontal force. See, there is no horizontal force, so this will get 0. This will also get 0. Now extend this part and draw the AFD, SFD and BMD. Okay, now you have to draw the AFD, SFD and BMD. Okay, now this one is your AFD. Okay, this is your D, this is your C. Now let's see. Now see, this will come, this will follow the compression. Compression means minus. Compression means minus, so you can draw over here. See, as I am explaining you that when minus sign is coming, draw inside the frame like this. See, when we are drawn with AB, we can draw here, and the part CD we can draw here. That's why I'm explaining you. We are standing over here. We are stand over here. We are seeing like this. See, in CD part this is inside part. In AB part this is inside part. So when minus sign will come, draw inside. When the plus sign come, draw outside. In CD part minus sign will come, draw inside. So it will be like this. Or you can write it over here, compression. This is your AFD part. Now what about SFD? Now draw the shear force diagram. See, there is no horizontal load, that's why shear force will be 0, and there is no horizontal load, that's why the bending moment also 0. This will also get 0, this will also get 0. This is your D, C and D. And here we will done this part of AFD, SFD and BMD. We can draw the all three members AB, BC and CD. Always remember these things. You are standing inside the frame. Minus part will be inside, plus part will be outside. Minus part will be inside, plus part will be outside. Thanks for watching my video. I hope you will understand this video. Do subscribe the Ekeeda channel. Thank you.